So for this drawing, what we're going to be doing is drawing objects that are simple, technically called platonic solids, and then adding value based on light logic. So the handout has that specific information, and what you're going to be doing is essentially copying those objects, essentially word for word, as best you can. So the first object that we have is a box. So the box that we're looking at is actually in 2-point perspective. So that means we start off with the corner, establish our size, right? It's a tall rectangle. Then establish sort of what we see diminishing. We're able to see on top of it, so that means that this diagonal is maybe going to angle a little bit more like that. And if it's a little off, that's okay. You're copying this. We're not using rulers for this. We're just trying to emulate what we see there. In our reference, and just trying to be conscientious of those perspective rules. All the verticals are parallel, right? All the diagonal lines or orthogonals vanish to, in this case, a vanishing point somewhere off in the distance, and another vanishing point somewhere off in the distance. In this case, is off the page. So we want to start sort of understanding that for the most part, we may not be able to include the vanishing points for the majority of things that we draw. But we do want to keep that same sense that we know that that vanishing point is somewhere over there, and this line eventually will meet there, and then this line also will eventually meet there somewhere. So it needs to start converging. They all need to start sort of converging towards a point somewhere over there. And these also need to almost parallel convergence, but it's a strange way to explain it, but they're all sort of vanishing to a point off in the distance. In this case, it's off the page. So that's the first box. That's the first volume that you're going to be drawing. So this is a solid object, so you don't need to draw through it. So what we need this for is to be able to describe the direction of light. So we'll draw them all just as a sketch, as line drawings first, and then we'll break them up, add the simple description of the shadow masses. So now I'm drawing the sphere, and the sphere is essentially a circle. You can cheat this by using something. The idea with this is that we're going to draw the shadow, which is the important thing, and not so much how well you render this. Actually, more how well you describe it, and less so how how accurately you can draw a circle. But to draw a good circle, one thing that I like to use is measuring tools. A stick is always something good. Instead of having to rely always on a ruler, I use a stick. So to do a circle, it's good to start with a box or a square. Bisect the square. Right, I find the middle this way and find the middle this way. And then I take the distance from the center of this to the edge and subdivide into thirds, just to make sure that my thirds are sort of equidistant. I'm a little shy of that. Good. So I'll keep that same measurement and go to all of the diagonals. So what I'll do then is just connect on a curve It's a little wonky. Oh, there it is. That's where it went off. That distance here is far too great. There. So we're going to edit this so it doesn't need to be perfect. For the cylinder, we want to start off with a rectangle, tall rectangle. We're able to see on top of it. We're all again at a 2-point perspective. This is going to converge back that way. I'm going to draw this a little quicker so we get a sense of what we're going to be doing, since we're going to be essentially doing this to get a nice ellipse. So all these construction lines get consumed into the drawing if you draw them light enough. If you go too heavy-handed, they don't get consumed. So with this, just the same as I did the circle, bisect, bisect, and this would have to converge. These lines are going to that imaginary, and now we can create that ellipse. So it kind of looks round. So when you have something like this, what you're doing is bisecting this again into thirds. But each one of these diagonals, not the straight ones, but the diagonals are the ones that get cut up into equal thirds. So then we'll do the same thing to the top around there. We can also project this line up. Project this line up. And now we know where this has to curve. Now we have a nice cylinder. Now, for the cone, we could do the box again. In this case, we can do a 1-point perspective. So we varied it a little bit from the 2-point, just to get a little bit more knowledge on how to do this. And then from here, to do the cone, we're going to go from the very center of this circle or oval, find the top of that cone, and draw a straight line. From here to here, draw a straight line. Now we have a cone. For the pyramid, a little bit easier. Same idea. We'll go with it 2-point. So again, we gotta go. This line converges back there somewhere. These lines converge somewhere off in the distance there. And then find the center of this by bisecting. Find the center, project that center up. And then connect. So I know where I'm starting, I know where I'm ending. Makes it easier to draw a line. And then the last one is the most difficult one. So for this one, we'll start off with same rectangular idea. Lines are converging. And now what we'll do is bisect. Find the center. And then bisect this again. Find the center. And that'll give us this top section and this bottom section of this hexagon there. And now we'll do it the same way this way. If it gets a little messy, it's a good idea to get rid of some of those lines so that we kind of have a good idea of what we're doing. Don't get all confused because this could get messy. But this is the most accurate way to draw this. So we'll go there, go there. Wherever these lines intersect, that's the middle. Wherever these lines intersect, that's the middle. So now we have this. Now we just connect the dots. And we project those lines back in perspective. We have all of our shapes.